here is that secant squared theta over cotangent theta minus tan cubed theta is equal to tan theta. And I'm going to be solving this trigonometric proof by working on the left side. And we know that secant theta in and of itself is equal to 1 over cos theta. So secant squared theta must be equal to 1 over cos squared theta, right? And then cotangent theta is basically the inverse of tan theta, and we know that tan theta is equal to sine theta over cos theta, so cotangent theta must equal to cos theta over sine theta, right? And then of course we're subtracting everything by tan cubed theta. So we need to multiply these. I mean, we can't just keep it a whole big fraction, right? So for us to do that, we basically need to keep the numerator the same, and then we need to multiply the inverse of the denominator, which is sine theta over cos theta. And we know that tan theta is equal to sine theta over cos theta. So basically tan cubed theta would equal to sine cubed theta over cos cubed theta, right? So when we multiply these ones, we basically get sine theta over cos cubed theta minus sine cubed theta over cos cubed theta, right? And so basically over here the denominators are the same, so we don't need to necessarily multiply them for us to be subtracting those. And so because we have similar values here, what we can do is we can factor them out. So basically if we want to take sine theta common, it would be 1 minus sine squared theta over cos cubed theta, right? And we know that 1 minus sine squared theta is equal to cos squared theta. It's an identity, so yes. So basically we just need to rewrite that into times cos squared theta over cos cubed theta. And now what we can do is we can basically get rid of the cos squared theta in the numerator and get rid of the 3, which we would then be left with sine theta over cos theta. And we know that sine theta over cos theta is equal to tan theta. So now left side is equal to right side, as we can see.